Integrated Math 2. All right, this is the second part of the answers video for your test review. And so what we're going to go over now is some of the graphing. And we're going to do what we did in class. This is simply what we did in class. If you felt like you understood it then you are fine. So I'm now on page 4 of, let me show you the assignment. I'm on page 4 of this, the Unit 2 Vertex Review. So that's what you're going to have a test on Thursday. And so we're going to go ahead and do the graphing of these. All right, very similar to what we did in class. All right, so I'm going to go ahead and copy the function down here. Okay, and we're going to go ahead and do this, graph this. So we're going to basically use the top half of a piece of paper. So I'm going to come over here right where that center hole is and just draw a line across. Right there. Okay, and over here we are going to make a table. So over here we're going to do our number work, and over here we're going to do our graphing. All right, so what we have is pattern of change. We'll just call it pattern. And that is going to be 1, 3, 5, 7, 9. And over here we're going to have our A value here. And the A value is the -2 in this problem. So we're just going to write -2 all the way down. And then here we're going to have our pattern for this problem. Okay, so I'll just write it like that. So you simply multiply these two together. I'll use a dot so it doesn't look like a variable x. So 1 times -2 is -2. 3 times -2 is -6. 5 times -2 is -10. 7 times -2 is -14. And -18. Okay. All right, so I used the entire piece of paper in class, but here I am going to just use half of it, and so we're going to practice scaling our graph here. So first we need to know the vertex. We need to know two things. And I'll ask you these so that to kind of prompt you on how to do this on the test. The vertex. Remember, it's the opposite of this number for the x-coordinate and this number exactly for the y-coordinate. So the vertex's coordinates are going to be, the opposite of this is 1, and this number is -1. That's going to be the vertex. The other thing you need to know is concave. Either up or down, and this is down. That's a negative sign there. That means it's a frown face. Concave down. So what I'm going to do is I'm going to put my xy axis right about here. I'm not going to draw. It's not a big dot. It's just where the two axes intersect. So here's the x-axis, and here's the y-axis. Okay. Now you'll be given a graph on the test that'll already be scaled for you enough, okay? You don't have to do this part, but you do here. So let's see, I am going to go, the first time I move over, I'm going to go down 2, then I'm going to go down 6 more, that's 8, and then I'm going to go down 10 more, that's 18. So I'm going to count each one of these as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I'm going to make each of these over here, and I tell you what, I'm going to put it out here. Each line is going to be 2, so -2, -4. So I'm just scaling my axis here. I just want to do it off to the side so it doesn't get in the way of the graph. Okay, now on the x-axis you can use different, you don't have to go every 2 like we did here. So I'm going to go 1, it's going to be, I'll do it up here, it's going to be 1. Each square is going to equal 1, what it usually does, what we're used to seeing, okay? 5, 6, 7, we're not going to go out this far right there. Okay, so now we have the vertex is 1, so it's 1 in this direction, and -1. But remember, each square here is 2 going down, so I'm going to put it right there. Might make my counting a little trickier, but not too much, okay? So there's the vertex right there. That means the entire parabola is going to be down below the vertex. For a frown face parabola, a down parabola, it's going to be, the vertex is the highest point. Remember that, okay? Okay, so here we go. We go over 1, and we're going to go down 2. So I'm going to go over 1, and down 2 is going to be the equivalent of 1 box. So it's going to be right there. So that's the equivalent of 1 box right there, going from here to there. Okay, now we're going to go over 1, and we're going to go down 6. So over 1, and that's 2, 4, 6 right there. All right, so now that puts us there. So where is it? That's 2, 4, 6, 8, 9. We're right there at 9. Okay, now we're going to go over 1 more, and we're going to go down 10 more here. So it's 2, 4, 6, 8, 10 right there. Curve down like this and like that. When we go in the other direction, we go back 1 and we line it up with that dot right there. We go back 1 and we line it up with this dot right here. We go, this should be halfway actually. We go back 1 and we line it up with this dot down here. And so the curvature goes like that. Okay, so what you'll be asked to do is to write this pattern of change, how that works. So let's review it. The pattern of change for the parent, let's call this the parent pattern of change. It's for any x squared function. The difference is going to be 1, 3, 5, 7, 9. Why? In other words, 1 squared is 1. 2 squared is 4. So the difference between 1 and 4 is 3. 3 squared is 9. The difference between 4 and 9 is 5. 4 squared is 16. The difference between 9 and 16 is 7. So these are the differences between each of the numbers when you plot an x squared. All right, and then you multiply it by whatever your a is for this particular. So the pattern for this problem is going to be 1 times -2, 3 times -2, 5 times -2, whatever that a value is. Okay, and then you just remember that what this means is for every 1 you go to the right, you go down 2. The next time you go 1 to the right, you go down 6 more from the 2, from where you were there to there. You go 1 more to the right, you go down 10 more. So that's 2 squares on this, 2, 4, 6, 8, 10. Okay? All right. Let's keep going. The next function is this one. We're on page 4 of this review assignment. So that's a 1 out in front of that x squared. So we're going to write that. So it's 1 times x plus 2 squared plus 1. Okay, we come over here and we write the parent pattern. I'm actually going to use the entire page this time. Well, no, I don't. I don't need to this time, actually. The parent pattern of change, the a value, and this pattern for this problem. Okay, so the parent pattern is always for these 1, 3, 5, 7, 9. You could go on forever. Okay, and this one's going to be just a 1, so that makes it really easy. And it's a positive 1. So it's 1 times 1 is 1, 1 times 3 is 3, 1 times 5 is 5, 7, 9. Okay, so again, the two questions are, what is the vertex? It's the opposite of this number for x, so it's -2. And it's this number for y. And then concave. And it's going to be positive number there. We just emphasize that by putting a plus sign. You don't have to. So it's up. Okay, so again, I'm just going to use half the page here. All right, so I'm going to put, since it's going up, we know this thing's going to go up, and there's the vertex. I'm going to put the origin right about here, okay, and here, like that. Okay, so I'm going to count every square as 1 this time. So that means the vertex is at -2, 1, so we go back 2 and down 1. So that's going to be the lowest point, and we know it's going to curve up like that, okay? So it's very simple. We go over 1, up 1. That's what this says. We go over 1 more, and we go up 3 more. So from here, it's over and 1, 2, 3. We go over 1 more and up 5 more. So 1, 1, 2, 3, 4, 5. And I really think that's enough. We go back, we go up 1, we just make it even with this dot right here. We go back and we go up to here, make it even with that dot right there. Go over 1 and go up 1, 2, 3, 4, 5 right there. It's even with that dot. And so there we go. Okay. Doesn't care. I don't care if that's pretty or not. Here's what I'm going to ask you to show me. Tell me what the vertex is. Tell me whether it's concave up or down, and write this table out. I'll give you the table. You just have to fill in the numbers. Okay? So it won't be that hard. Okay, we only have one more of these. It happens to be another -2. I wish they hadn't done that. I wish they'd given us a different number. But here's the function. And I'm getting it from right here, down here at the bottom of page 4 on this assignment. All right, so parent pattern, A, and this problem's pattern, I'm just going to call that this pattern. Parent pattern is always this. You can keep going, but we're not even going to do this many numbers. Okay, there's A right there. So we multiply them just like we did in the first problem. We get -2 there. 3 times 2, let me put the dot for the multiplication. 3 times -2 is -6. 5 times -2 is -10. 7 times -2 is -14. 9 times -2 is -18. All right, so first thing we're going to find out is what's the vertex. And it's at the opposite of this, so that's -5. And exactly this number, so that's -3. Okay, and it's concave down because of that negative sign. Okay, so -5, -3 is going to be down kind of low from the axis. So I'm going to come here. I'm going to make my axes. There's the y-axis. And there's the x-axis. All right, so here's the origin. So -5 is 1, 2, 3, 4, 5, 2, 3. Okay. All right, so that is the vertex, and that's going to be the highest point because it's a concave down graph, so that's going to be the highest point. So we're going to come over 1, and we're going to go down 2. And we might as well do the other direction at the same time. We're going to go back 1 and down 2. Doesn't matter what order you do these in. Then we're going to go down over another 1 and down 6 more. 1, 2, 3, 4, 5, 6. And over this way, and 1, 2, 3, 4, 5, 6. And that's as far as I'm going to be able to go without going off the graph, and that's good enough. All right, so this is going to come down like this. This is going to come down like this. And that's your answer. That's all you're going to need to do on the test, is that much information. Okay, so practice these. Just watching them one time is not good enough. You need to take out a piece of paper, practice them, be sure you can do them on your own before you get on the test. Okay, that takes care of the graphing that you're going to be asked to do, and we'll see you in class.